So my name's Doug Kirshner, and I'm a program manager on the Windows accessibility team. I've been working on accessibility for about 3.5 years now. I've mostly been working on Narrator, which is the screen reader in Windows, and more recently helping out with Narrator on Windows Phone, which is new for Windows Phone 8.1. I've also had the opportunity, while working on accessibility, to work with a lot of different teams around Microsoft as they build applications on Windows to figure out how best to make those applications accessible. So today I'm going to share some of the things that we've learned from working with those teams and some tips and tricks for how you can make your app accessible, and first and foremost, why you should make your app accessible. So I'll start off by giving a little bit of an overview of accessibility. I realize this is the only accessibility session at the conference, so I'll give a little bit of an overview of what accessibility is, why you should care about it, and what it means for Windows Store apps. Talk a little bit about what Windows offers in terms of accessibility, both in terms of what we offer to end users as well as how it's architected in Windows. And then we'll work through actually building an app, a tic-tac-toe app, and making it accessible using XAML and C#. So I'm going to start out by showing a video. The audio on?
What can it do?
When I lost my eyesight, I thought that my painting days were over.
Sorry? Oh, it's not showing. Let's see. Oh, is it just PowerPoint that's projecting? Sorry about that. Let's see. There we go. Dual monitors. All right, let's try this again.
Those field goals. Look out! Right through! A pick block by Steve Gleason! Touchdown, New Orleans!
It's kind of unbelievable that Steve has a statue.
The statue is not about football. It's a symbol of the people in this region who chose to return and rebuild. I have ALS. With ALS, a person loses the ability to move and breathe on their own. I communicate verbally with the eye tracking technology.
I am Michelle Veriska Gleason. I am the wife of Steve Gleason and the mother of Rivers Gleason. Team Gleason is a foundation that Steve and I started a year after Steve was diagnosed.
Part of our mission is to raise awareness of this disease, and specifically to help other people with ALS to live their lives as best they can.
Communication is a key element to our quality of life. The eye tracking technology runs on Windows, and Surface was the latest product we have discovered where it was enabled.
All day he's on his computer, whether he's tweeting or he's speaking. It's powerful enough for him, which is huge. I think fatherhood means almost everything to Steve.
Rivers, are you showing off?
With Rivers, it's created a special bond that many fathers and sons will never have.
He's able to get some physical time with Rivers because he'll climb up on his lap. Steve, when they're watching movies together, can talk back and forth to Rivers about what's going on. And the time that he has with Rivers on his lap, I think it's safe to say, are his favorite times.
They say your eyes are the window to your soul. I suppose this means the technology allows me to bare my soul. Although I'm hopeful for a medical cure for ALS, I have always said, until there is one, technology is my cure.
All right, so some of you probably saw Steve Gleason narrate the Super Bowl commercial, but I just wanted to show that because that really gets to the point of why we care about accessibility. It can make a huge difference on people's lives. And in this case, it can make a difference between being able to communicate or not being able to communicate. Technology is the reason why people who are fully blind can be fully productive information workers alongside sighted colleagues. So though technology has certainly benefited us all in various ways, it's especially true for people with disabilities. So I'm just going to share a few terms. Let me just get rid of the taskbar there. When we talk about accessibility, we're really talking about enabling as many people as possible. And when we talk about software, we're talking about including people with disabilities and testing to ensure that those people with disabilities can interact with a given app or service. And when I say disability, I'm really talking about a continuum. Obviously, there are some severe disabilities like blindness and paralysis, but a lot of people might not think of themselves as having a disability, but might still have trouble completing a task. For example, for some people, it might be really hard to read fonts on the screen if they're small or not high enough contrast. And that doesn't necessarily mean that these users consider themselves to have a disability, but they are prevented from being able to interact with your app. So it's important to think about the capabilities of your users and everything that they can do in order to interact with your app. And the last concept I want to bring up is universal design. So I'm just going to give a quick example of this. How many people in this room prefer sometimes to use keyboard shortcuts rather than the mouse? Okay, that looks like, to a first order of magnitude, everyone. And I imagine that most of you don't actually consider yourselves to have a disability, and you're not doing it because of any disability, it's just faster. So the idea of universal design is that we can design things that work well for everyone. And as you'll see in a moment, you leverage your investments in accessibility to build a better user experience for everyone. I'm just going to show some quick statistics here on the percentage of people with disabilities in the United States. You'll notice that there's a big difference as users age. In the 65+ category, it's a much larger percentage of users, but it's a significant percentage of users below 65 as well. And you can imagine that as the population in the United States and other countries continues to gradually grow older, the number of people with disabilities using your apps is not going to decline significantly. So this brings me to wrap up our overview of accessibility and talk about why your apps should be made accessible. For one thing, hopefully by now, you'll realize that it's just the right thing to do. An app that is accessible is more inclusive, enables more people to use it. It can take a very small amount of your time to make your app accessible, but it can make a very large difference for somebody with a disability who might be unable to use your app otherwise. As I talked about with keyboard shortcuts and universal design, building an app that's accessible to users with disabilities, at the very least, is no worse for everyone else, and in many cases, leads to a better user experience for all users. Additionally, there's some other things you should be aware of. There are some legal requirements. For example, the 21st Century Communications and Video Accessibility Act, which requires that certain communications devices be accessible to people with disabilities. And it varies according to different markets and stuff like that. So if you're interested in more info on that, check with your lawyer as to whether that might apply to you. And then lastly, you get a larger customer base, both due to direct sales to users, as well as being able to sell to organizations such as governments that might be covered under Section 508 or other legal requirements. So next, I just want to talk a little bit about some of the things that Windows does to support these users. As I mentioned earlier, disabilities are really a continuum. It varies from some people that might just have trouble seeing the screen to other people that might not be able to use their hands at all. And Windows offers several levels of support for users. I start with system settings. And you can see there are certain settings that I have put in bold here. These are the ones that are also available on Windows Phone. So in system settings, you can increase the font size, change the contrast, change the way the keyboard and mouse works if you have mobility issues or fine motor control that affects your ability to work with those, and sort of tune the system. There are a lot more system settings than just what's shown here, but this is just a sampling. At the next level, we have what we call assistive technologies, and you may hear me refer to assistive technologies for the rest of the talk as ATs. And these are actually programs that run on the system that allow a user to interact with the system through another program. And we have a number of assistive technologies that come with Windows automatically, including Narrator and Magnifier, Narrator being the one I've worked on a lot and being now available on Windows Phone as well. But there's also a third-party ecosystem, including eye tracking hardware and software, screen magnification, third-party screen readers, voice dictation systems, et cetera. And the third-party ecosystem really enables third-party vendors to build very specific solutions to cover a whole wide range of disabilities. So as a developer, though, we can focus on a few key things to make sure that your app will work with all of these different solutions. We don't have to tailor to each one individually. This is a brief overview of how accessibility works in Windows. So you've got your Windows Store apps and for Windows and Windows Phone, and then you've got your UI frameworks. And I built this diagram around Windows, but if you are building a Windows Phone app, of course, there's Silverlight on there. And all of these UI frameworks map into what we call UI automation. And UI automation is the plumbing which connects the ATs, assistive technologies, to your app. So it, for example, allows a screen reader to get information from your app and read it out to the user. So all of the UI frameworks feed into UI automation. But the exact way you do accessibility work in each of the UI frameworks will vary. Accessibility is really about a user experience. And so how you build your user experience varies, so will how you do your accessibility. Today, we're going to talk about one path through this system. And we're going to show building a XAML app using C#. And we're going to look at making that work with Narrator and the on-screen keyboard. You notice the on-screen keyboard is not the touch keyboard that you may be familiar with in Windows. This is actually a simulated keyboard specifically for accessibility, so it's a little bit different. I just want to avoid some confusion there. Also, the on-screen keyboard in this diagram isn't connected to UI automation because it just simulates a keyboard and sends key input. It's actually that simple. So next, I'm going to just show you some examples of how users with disabilities might interact with your app. And I'm going to do that by demonstrating the on-screen keyboard, which I just mentioned, as well as Narrator. Switch over to Demo Machine. OK. So first thing I'm going to show is the on-screen keyboard. All right. So this is the on-screen keyboard in Windows. And what the on-screen keyboard enables people to do is it enables users with severe mobility impairments to interact with the system through a virtual keyboard. As you may be aware, the entire system can be controlled using the keyboard. So with this intermediate area, if a user with a disability is able to interact with the virtual keyboard, they can, by proxy, be able to interact with all the functionality of the system. So imagine a user with very limited mobility who can only interact, for example, by blowing into a tube or pressing a single input switch in some way. A pretty extreme case, but a very realistic case. That user could actually use the system using scan mode on the on-screen keyboard. And the way scan mode works, I'm going to demonstrate it using the spacebar here, is it'll scan through the various keys on the keyboard. When you get to the row you want, you trigger your switch, and then when you get to the group you want, you trigger the switch again, and then again on the individual key. So if I want to press the Windows key, for example, I'll go like this, and like that to launch a start menu. Now, that may seem like it would take a very long time to interact with the system that way, but once you get used to this, you can actually turn up the speed and be pretty efficient using it. Also, if you're using an eye tracking system, for example, the on-screen keyboard supports hover mode. So you could gaze at a key for a moment, and it would insert the key. And that's actually what you saw Steve Gleason in the video doing with a third-party system for eye tracking as well. What this means to us as developers is that in order to make our apps accessible, we need to make sure that they can be fully controlled using the keyboard. And if we do that, then users with severe mobility impairments will be able to use our apps. Close that for a moment. The other thing I'm going to show is Narrator. So Narrator is a screen reader, which enables users who are blind to interact with the system.
Start menu, pane, calendar.
OK. So you're going to see some black dots up here. That represents my touch points on the screen. Narrator allows me to touch the screen and hear what's there without interacting with it.
Weather, 54 degrees. Desktop double tap to activate, triple tap to select.
So I can drag my finger around the screen, and you notice that when I touch those items, it doesn't launch them. It just reads out what's under my finger. If I actually want to interact with those items, I could double tap anywhere on the screen, and it would effectively click on that item or tap that item. I also don't even need to be able to find things on the screen using my finger. Without knowing anything about the screen, I can just do a gesture, so a single finger flick to the right or left to step through the various items on the screen.
People double tap to activate. Skype calendar. Skype people desktop double tap to activate.
You saw me do a 2-finger tap right there. That's my gesture that I use in presentations a lot so that I don't have to speak over narrator. It basically stops narrator from talking. So if I do a double tap, you can see laptop screen is tough. Then
Exiting narrator.
activate the desktop. Now I'll exit narrator for a moment and switch back to the presentation. So that's just a little bit of an example of how users with various severe disabilities can interact with the machine. And you'll notice it's vastly different depending on the user's unique abilities. So now let's talk about how we actually go about building an app that can work with all these varied modes of interaction. So what we're going to do is we're going to build a tic-tac-toe app. How many of you here took the Dev Challenge? Okay, a couple. Yeah, there was a little tic-tac-toe app there. We're going to build a little bit more complicated tic-tac-toe app because we want to demonstrate how to make various types of UI accessible. And we're going to work on making it accessible to people with mobility and visual impairments. These are sort of the main canonical examples that you should worry about when designing your apps. So here's the design workflow we're going to propose, and this should look pretty familiar to the design workflow that you might use in building your own app, except that you'll notice we're doing 2 things specific to accessibility, both ways of testing the accessibility at the end, using SDK tools and also using the ATs and accessible scenarios themselves to verify the user experience. So the first part of designing an app with accessibility in mind is identifying your scenarios. Same thing you'd want to do whether or not you're thinking about accessibility. But what we're going to do is we're going to identify the scenarios up front so that when we get to testing the experience later, we'll know how to validate whether or not the scenarios can be achieved by a user using an assistive technology. So here's the scenarios for tic-tac-toe. It's going to be a pretty simple game. We're going to need to be able to configure the parameters and start the game. Makes sense. We're going to need to be able to play the game by adding X's and O's to the board. And we're also going to need to be able to know when the opponent makes a move or when the game is over or the game starts, etc. So these are the scenarios that we're going to care about for both accessibility use cases as well as every other use case. Next step, we're going to build the app with accessibility. That is, do all known accessibility work. And for that, I've already built the app, so I'm just going to show you what we built. Cool. So this is the tic-tac-toe app. As you can see, it's pretty simple. You can select whether you're playing X's or O's. You can choose the difficulty, easy, medium, or hard. And when you're ready to go, you go start game, and now you can play the game putting X's and O's. After a little bit of thought, the computer will go ahead and make a move, and you can play as such. So one thing I want to point out before I move on actually is if you look on the right-hand side, you'll see a lot of mostly common controls. The radio button's totally standard. The start game button, just a button, normal button in XAML. And the slider down there is slightly customized. It's a normal slider, but what I've done is I've changed it so that it'll say easy, medium, or hard on the right, and I've added a label and sort of hooked it up so that it'll update when the slider moves. But most of that stuff is pretty common. On the left-hand side, you'll see a highly custom control where I've built my own sort of text controls that you can tap on, and they can change to X's and O's and arrange them in a grid and set that all up. I've subclassed XAML controls of my own and built that. So I'm going to switch back to. Okay. So that's our tic-tac-toe app. So now we've identified the scenarios. We've built the app, at least to a first approximation with accessibility. And now we want to actually validate that users with disabilities can use this. So the first thing we're going to do is we're going to start by leveraging the SDK tools that are provided. And the first tool I'm going to talk about is something called ActScope. Now, ActScope allows you to visualize the accessibility, like data overlay of your app. So ActScope has a couple different modes, but one of the things you can do is get this overlay mode. And I apologize, there's a number of transparencies on here. Contrast isn't great. But what we've got here is we've got overlays showing what are the controls that an assistive technology is likely to focus on in this app. So you can see we've got the 9 squares in the tic-tac-toe board, and we've got the tic-tac-toe label, and we've got the radio buttons, and the start game button, and the slider, and the game status notification, as I call it. That looks pretty good. There's one thing that's slightly suboptimal here, and it's somewhat subtle. It was a little bit of a contrived example, but you might notice that the slider is actually 3 different controls, and that's a little bit inefficient. It really should be thought of as one control. If the user, we just added a couple labels to the slider, and we really just want that to be one thing. So the easiest thing to do with this is use the accessibility view property to hide the extra labels that are part of the slider's data anyway. So there's this property, accessibility view, and it takes 3 values: raw, control, content. Control and content values are exactly what it sounds like, controls and content. And what that does is it tells an assistive technology, hey, these are controls and content, like they're pretty interesting. Raw, which is the 3rd value, basically tells an assistive technology that, hey, this is here, but it's not really part of the control or content. Like it's sort of an other category, if you will. So by setting these to raw, and you'll notice that we also set the labeled by property on the slider so that it picks up the label from its name. It picks up its name from the label above it. By doing that, you'll see we've reduced the slider to a single control, and you probably can't see it from the back, but the tool also allows you to see the name of the control is difficulty. So it's a slider and its name is difficulty, and that's what we want. So that's great. Another tool that we encourage you to run in your app is Accessibility Checker. So Accessibility Checker is an automated way of testing accessibility. It'll tab through your app, it'll test via UI automation the structure of your app to make sure that you can navigate everywhere, that all the control patterns are in the right spots, etc. And if we go ahead and run Accessibility Checker on Tic-Tac-Toe, you're going to get a readout that looks something like this. And what you'll see is there's a list of errors there. There's a description of the errors. You can right-click on them and go to MSDN, and there's a diagram down in the lower right-hand corner which will actually highlight which control you're talking about. So if you look at any of these errors, what they're saying is element has no name. These errors are saying element has no name, and there's 9 of them, and they correspond to the 9 squares. Well, pretty simple. We forgot to set a name. And actually, if you were watching closely, you could have spotted that with ActScope as well in the previous example because there were no written labels on those. So let's add a name. And just a few tips and tricks about picking a good name. You might think it would be tempting to say Tic-Tac-Toe Square is a good name for the Tic-Tac-Toe squares. But there's a couple problems with that. First of all, every square on there is going to be Tic-Tac-Toe Square. They're all the same thing, but they represent different things. Secondly, Tic-Tac-Toe Square is kind of redundant. You're in Tic-Tac-Toe app, so you don't necessarily want to put Tic-Tac-Toe Square. So names should be short and concise, and they should also be consistent with the text on the screen, which is an X or an O or an empty cell, right? But that text isn't represented in the name either. And they should also be unique. So a bunch of controls shouldn't have the same name. And in fact, if we named them all the same thing, and you went and ran Accessibility Checker, it would find that, oh, these controls have a similar name. It might be hard for a screen reader user to distinguish between them. So what we're going to do instead is we're going to use the text that's visually displayed on the screen, and we're also going to add a little bit of extra text to say, this is upper left square, This is the bottom right square. This is the middle center square, etc. Cool. So those are a couple SDK tools that you can use. Those tools are both good tools for sort of running and getting a higher level look at your app. There's other tools which I'll include a link to later, which allow you to debug further what's going on if there is a problem. The nice thing about using the tools is if you find an error with the tools, it's usually a lot easier to figure out what the error is, why it's happening, et cetera. If you just jump straight into testing with the assistive technologies, it's going to be harder to debug what the problem is if you encounter any problems. So now we're going to test the key user experience scenarios. And the first thing we're going to do is we're going to test with keyboards. I'm going to switch back to demo. All right, so here we are in tic-tac-toe. And you probably can't see the keyboard focus rectangles very well, but turns out, yeah, I can tab around, I can move the difficulty, easy, medium, hard. That looks great. I can go ahead and set the X's or O's, and I can start the game. So our first scenario, configure and start the game, it works with keyboard, we're good. Second scenario, as you may remember, was make sure that we can play the game and put X's and O's on the board. So come over here, turns out, okay, I can tab around the squares. I really want to just arrow up and down, but I can't. Okay, so tabbing is a little bit inefficient way to get around this grid, but okay, so it'd be nicer if I could arrow. And let me try to put something in this square. So I'm going to try space or enter are the common ways to activate something, but neither of those is really doing anything. Interesting. So we have a bit of a problem. You actually can't play the game with the keyboard. So that means a user reliant on the on-screen keyboard, that virtual keyboard that mobility-impaired users might need to use, can't actually use this app. So this was pretty easy to spot. We just tried to use our app with keyboard, and it's pretty easy to fix, too. So we're going to come over here, switch back to the code, and stop debugging. All right, so what I'm going to do here is I've already set up some keyboard handlers. Just going to uncomment them. These are really pretty simple. We look for right, left, up, down arrows. We move the focus appropriately if we see any of those keys. And then lastly, we look for space or enter, and we make sure that you're allowed to make a turn, and we make a turn. Make a move, that is. So that's great. All I have to do is run this again. Go ahead and start the game, and I can arrow around now. I can go up, down, left, right. And space or enter will activate the cell so that I can actually put the X's and O's into the board. And now our third scenario was observe the opponent's moves and game state changes. That's pretty simple because in this case you can do it visually. You can see the updating status on the right, and you can also see when the computer puts an O in one of the squares. So great. There's our scenarios. We can do them all with keyboard. This app is officially accessible via keyboard. And now anybody who's reliant on keyboard-based solutions or anybody who prefers using the keyboard can use this app more effectively. You can imagine on a trackpad on a laptop, if I'm playing tic-tac-toe, it might be kind of annoying to mouse around and click the squares. It's a lot easier if you can just arrow around and press space to insert the X's and O's. So we've made a better app for everyone. Okay. So these slides just summarize the problem. We had an inefficient navigation model, and you couldn't put stuff in the squares. We changed that. Now you can. So the next thing that we're going to do is we're going to focus on the users with visual impairments. So we need to do a couple things for this. First of all, we have a range of users. Users with visual impairments might be just slightly hard of eyesight, or they might be fully blind. And there's a number of different ways that they could be interacting with the system. One of those being high contrast mode, one of those being magnification, one of those being using large fonts, one of those being using screen reading, etc. The two that mainly impact apps are the high contrast and the screen reading. Magnification and large fonts are pretty simple. They just do basic scaling. But high contrast will actually change the colors in your app, and screen reading will actually interact with your app in order to get data to render verbally to the user. So those are the two we're going to focus on for our scenarios here. So what we're going to do is we're going to switch back and test the app using high contrast. So high contrast is system setting. So I'm going to go over to PC settings and move into ease of access, high contrast. Now all we need to do to test this app with high contrast is run it under high contrast. So we're going to go to high contrast black. We're going to switch the theme, apply that. Great. Now we're going to go back to tic-tac-toe, and looks like it works. You can see, you can configure the game. The nice thing about high contrast is it's just purely visual, so it doesn't affect the functionality of your app. So you can still use all those controls. I can still click on squares. You can see the opponent making a move, and you can see the game status label updating. So our scenarios work with high contrast black. The other one we should test is high contrast white, just because it flips everything in the opposite direction. So we'll test high contrast white. And oh no. So we went back to tic-tac-toe, and you remember we were actually already playing the game. But the X's and O's that are already on the board are completely invisible now. So this is because I've hard-coded the color of the X's and O's to be white, because I've made the assumption when building my app that it's always going to look the way that it currently looks. But when I move to high contrast theme, high contrast updates all the colors in XAML that it knows about, and those that it doesn't stay the same. So it's updated the background color to be white, but my X's and O's are still white, so you can't see them at all. So this is actually fairly easy to fix as well. We're going to come back here. And what I've done is in my defined styles in my XAML, I've defined the style of the X's and O's to be a foreground color white. So in order to fix that, I'm just going to switch over to, I've got to stop first. To switch that, I'm just going to comment out this line and replace it with this line. And in this line, I'm doing the same thing, but I'm using a theme resource color. The reason to use a theme resource color is that when you switch into high contrast mode, these colors will be updated automatically. So I don't have to worry about it now. I'm just using a theme resource color based on the system window text. And now, if I go ahead and run the app, okay, let's start it over so we don't have a game going yet. My X's and O's are now visible. The great thing about high contrast is you really just have to turn it on and run it. It's really easy visually to spot any high contrast bugs. And it'll make a difference to users who have limited vision but can still rely on their vision as long as the contrast ratios are sufficient. So what I'm going to do now is I'm going to actually just turn off high contrast, just so it's not confusing to anybody who's used to the normal themes. And I'm going to switch back to here. Great. So we tested with high contrast, we found a problem. Our key visuals, namely the X's and O's in our board, were completely invisible when we switched into high contrast. Pretty easy to fix. We used a theme resource, and now they update automatically. So next step, as I mentioned, there are two things that we want to test for the users with visual impairments, one being the high contrast and two being with narrator. So, or you can also use other screen readers, but we're going to use narrator because it's built into Windows. And what we're going to do is we're going to run through our scenarios using narrator as well. And it's important to remember when using narrator that it doesn't matter so much what you see, it matters what you hear. So I'm going to switch back to demoing this. So I launched narrator with Windows Enter, which is a keyboard
Tic-tac-toe
shortcut.
window. Selected. X's.
So that's great. And now we already made this app accessible via keyboard, which is important for users who are blind as well. If they're using a touch-based system, they'll use touch. But otherwise, for a user using a screen reader, it's generally easier to use a physical keyboard rather than a mouse, which is based on locations on the screen, which, due to the user's capabilities, they can't see. So
O's.
I can tab
Radio
around.
button. Start game button. O's. Selected. X's.
Okay.
Radio O's. Start game button.
That all looks good. I can use flicks to move around the items.
O's. Selected. Player choice. Tic-tac-toe.
Okay,
Player
good.
selected. O. Start game but difficulty 50%. Slider double tap to increase value, triple tap to decrease value.
Okay, anybody notice what's wrong there? Yeah, it says 50%, right? So, but it doesn't tell you like what the slider's actually at, right? So you don't know whether that's medium, hard, easy. Basically, we're not showing what the sighted user actually sees when they look at the slider. We're saying 50%. So if we went actually and debugged this a little bit further using some of the testing tools that I mentioned, what we discover is that actually the medium, hard, easy is not exposed on the slider. Even though we put it sort of in the raw view earlier, that also wouldn't matter because it's not focused by narrator right now either. So what we need to do is we need to add this accessibility data to the slider. So the way that
Enter. Exiting narrator.
automation works in XAML is through what we call automation peers. So each element has a corresponding automation peer representing it. And in this case, what we've done is we've made a customized slider. And the slider has an automation peer representing a slider that tells you, oh, this slider's at position 1 out of 2. But it doesn't necessarily know that we've added this extra label and hooked all this up. So the slider automation peer needs to be replaced with our own slightly customized slider automation peer. And the way we do that is as follows. I'm just going to uncomment out this group of code. So here I've defined my own implementation of the automation peer. And what I've done is I've extended the base class of the slider automation peer because I want most of the accessibility functionality of a slider. I just want to make one little change. And my one little change is that my version of the difficulty slider automation peer implements iValueProvider. Now, iValueProvider allows the control to have a string value. And if you look in the MSDN documentation, you can see the full list of what we call control patterns that are available to apply to a given automation peer. So there's a lot of stuff here I just do for tracking variables, but the meat of it is that iValueProvider implements these methods, setValue, isReadOnly, and value. And if you look at the value, I've changed the accessor of this control to return easy, medium, or hard, depending on the value of the slider. So that will just return a string value. And then the one last thing I need to do, I've defined my customized automation peer. I also need to return that customized automation peer by overriding this method on createAutomationPeer. This is just the method, and you can find this in the documentation on MSDN. But this is the method that you need to override in order to ensure that your custom automation peer gets used and not the default one, which would be used for a slider. So now, if I go ahead and run this again, try our scenario.
Tic-tac-toe window. Selected. O's. Start game button, double tap to activate. Difficulty. Slider at medium, double tap to increase value, triple tap to decrease value. Easy. Medium. Hard. Medium.
So now when I adjust the slider value, when I read the slider, it will read out the value that I provided rather than the default value for the slider.
With exiting narrator.
So that's great. We fixed that problem. The slider read the percentage, not the difficulty. There's one other thing I want to switch back and test real quick, which is the rest of the scenarios. So let me just bring this back up.
Tick.
So great, we can move through, we can start the game.
Start game button, double tap to activate. Empty, middle center.
Okay.
Start game disabled.
Now we're looking at our second scenario. Can we add X's and O's to the board? Turns out,
X middle center.
again, works. We hooked up that other stuff with keyboard accessibility. XAML just took care of it, and this automatically works. But the third thing we need to do is make sure that we can observe the opponent's moves and the current game state. So you'll notice what happened there. The opponent made a move by putting an O in the lower right-hand corner. but we didn't hear anything about it. So if I keep playing, you'll see
Empty, middle left. X middle left.
this game status label is updating, and also the opponent is adding O's to the board, and I'm not hearing anything about it. So this is really broken if I'm a user who's blind trying to use this app. So how do we fix this? Well, it turns out that we can fix this with a concept known as live regions. And by the way, there isn't really any way of catching this with automation, because only you as an app developer will know what the important things are that are changing away from where the user is focused.
Enter. Exiting narrator.
So I'm going to come back one more time into the code. All right, so there's two things we want to change. One, that game status label that's updating, and then two, the X's and O's that the opponent is putting on the board. So if we want to enable these live regions, we need to do two things. One, we need to identify the live setting on the control. So the live setting by default for most controls is off, meaning this isn't a live region. The other two possible values for live setting are assertive and polite. If you set a control as having a live setting of assertive, what that means is that this should interrupt anything that's going on and tell the user right away. If you set the live setting to polite, then that says the user should be notified of this, but it doesn't need to happen right away. Just notify them if and when there's time. And that gives a little bit of a hint to a screen reader or other assistive technology in how to handle the event so that it can prioritize between different events and know which one to read first, etc. So for the game status label on the side, this is sort of casual game updates. Like, oh, you should know it's your turn now, etc. But it doesn't need to be assertive. So I'm going to set this by setting the live setting of the game status label to polite. And that's what I've done here. The second thing you need to do to enable live regions is actually raise an event. So I'm going to come down here, and I want to raise an event every time the game status label changes, so that assistive technology will know, oh, this updated, like maybe I should read it. So to do that, I have two lines of code here. First one just gets the existing automation PR for that element, because that's the object on which I can actually raise the event. So I'm going to go ahead and do that, and I'm going to raise the live region changed event every time the game status label changes. So that's great. Now I also want to do that for opponent's moves, so I'm going to come over here, and I'm going to find the same thing. But in this case, the opponent's moves happen right away, and I want to know about it right away. So I'm going to set the live setting on these to assertive. So same thing I did earlier. I'm just going to set the live setting on each square. This is in my board class, so I'm referencing the specific square, which I have in an array. And I'm going to set the live setting to assertive. So I'll go ahead and save that, and I also need to raise the event. This is exactly the same as I just showed. Now I'm going to run this once more.
Tic-tac-toe window. Selected. X's. O's. Start game button double tap. Start game. Your turn. X middle center. Opponent's turn. O top center. Your turn.
And now you'll see narrator will read out these updates to me even though they're happening away from where the user is focused. So with live regions, we've enabled the user to fully play this game. They can make a move, and then when the computer makes a move, narrator will announce that move to them. It will announce whose turn it is. If the game is over, it will announce game over, you won, you lost, etc. So
Tic-tac-toe window. Enter. Exiting narrator.
Turn off narrator. Switch back here. All right, so as we saw, the game updates and opponent's moves were not read. So we fixed this by adding live region support so that the screen reader is notified that, hey, something important is changing whether or not you're focused on it. And this is assertive or polite, meaning, oh, you should let the user know about this right away, or just let the user know if you can. So just to summarize, these are the 6 things we did to make tic-tac-toe accessible in terms of code. They're all pretty straightforward, but it requires actually thinking about how a user is going to use the app and testing. They were all pretty straightforward to fix once we found them, but they'll make a huge difference to anybody using this app with an assistive technology, anybody using this app under high contrast mode settings, etc. So we can now say that this app is accessible to users with visual impairments as well as users with mobility impairments. Here's just a couple bits of resources. So I have linked to the MSDN pages that describe what I talked about. If you are building an app with HTML and JavaScript, you'll find the link there to describe that. If you're building a desktop app, you'll want to find that as well. I have a link as well to Pramalini, my colleague's session from last year at this conference. She gave a little bit more of a introductory overview of accessibility using common controls. And then I also have a link here to all of the SDK tools, including the ones I showed, as well as some others that you might find really useful to you as you're building your apps. So one other thing, if you have any feedback on this section, please submit it, good or bad. I'd love to hear what you thought and how we can improve it. And with that, I think I have a little bit of time left, so I'll take a few questions. If anybody wants to come up to the microphones.
Do the SDK tools only work on the new common UI XAML, or they work currently with WPF, say?
Good question. So just because the mic got cut off a little bit there, he was asking whether the SDK tools work only with XAML or with, for instance, WPF or other frameworks. They're actually common to whatever framework you're using. The SDK tools are built on UI automation, which I showed that diagram where UI automation is the common framework between all of the UI frameworks and the assistive technologies. The tools are built off of UI automation, at least the tools that I've showed today and the tools that I've linked to. And so they'll work regardless of what framework you're using. How you do accessibility in different frameworks will vary by which framework you're using. So the specific code that I showed today is only applicable to XAML. So, any others? Yep.
How smooth is the integration with localization so that we can handle accessibility in foreign languages?
Yeah, so that should work the same way that you handle localization for your UI. Basically, you want to localize all of the strings that you use for accessibility in the same way that you localize them for your UI. Narrator itself, for example, is supported in about 15 languages depending on how you define it right now, and that's always going up. And there are other screen readers out there that support languages that Narrator doesn't support, and so it's important that if somebody is using a screen reader with a TTS engine in a certain language, that they will be able to actually read the strings. So you'll want to handle that the same way that you handle localization normally by loading a locale-specific resource for each one of the accessibility strings. Yep.
I saw you use the name property, the automation property's name attribute to call out the name of the control.
Yep.
One thing I had read is that some screen readers may or may not recognize that, and to also use the help text property. Is that?
Yeah, so screen readers make a lot of choices in deciding how to read a given UI. And in the case of Narrator and all others, there's probably various choices they'll make in terms of how to read it. The name property is the most important property to set from a automation correctness perspective. I don't actually know for third-party screen readers out there whether there are any issues with specific usages of name versus help text. Help text is meant to be a little bit different semantically in that it's meant to be auxiliary information. Some screen readers might read the help text right away anyway, so you may achieve certain results with some screen readers, but unless there is something blocking, I would try to stick with using the name for the name, because otherwise somebody building a screen reader designing to the standard of using the name as the name might not have the appropriate behavior for the app. So I don't know whether there are any specific issues that might come up by different screen readers, for example, not using the standard in the same way, but hopefully not. Name should be the right property. Okay? Well, if there's no other questions, I'll hang around here for a few more minutes. Got about 10 minutes left, so I can hang around and take some more questions up front if anybody has anything specific. Otherwise, thanks for coming, and please do submit feedback. Really appreciate knowing what you thought of the session. Thanks.